Okay, today we're going over Chapter 14 in Principles of Crop Production. This chapter deals with tillage and crop establishment. And first, the goals of tillage. There's several different type of things you hope to accomplish with tillage. One is incorporation of residues, partly so that, the residues will break down and provide nutrients for crops. And also control of crop pests, weeds, other things. And also tillage can be used for incorporation of things like manure, fertilizer, lime into the root zone. Preparation of a seed bed, it's important to have the proper seed bed, for the correct planting of a crop. And also just alteration of physical conditions and temperature of the soil, for growing conditions. And there's two types of tillage, conventional and conservation tillage. First, we'll go over conventional tillage, which is the more traditional type. It's also called traditional because it's the way things have been done for, years, kind of the older traditional way. And it's usually at least a two-step process. There's primary and secondary tillage. Primary tillage uses a plow to first turn the soil, and then you go over it again. The secondary tillage uses something like a harrow to smooth the soil out to make the proper seed bed. And historically, the traditional tool of primary tillage was the moldboard plow, which is showed here. It isn't used as much in some areas now, but a moldboard plow it actually goes in and totally shears off a section of sod and totally flips it over. And it usually cultivates to a 6-inch depth, but there's bigger plows that can mix soil to a greater depth than that. And it incorporates most of the crop residue that's on the surface, so if you use it, you won't have much crop residue left on the surface to protect the soil from erosion. And because of that, it leaves the surface bare and more vulnerable to erosion and washing by water. And usually less than 15% residue remains after moldboard plowing. And excessive plowing can lead to loss of soil organic matter over time. And then secondary tillage, which would be done after the primary, going over with a plow of some kind. After primary tillage, the secondary tillage equipment is used to smooth out and level the field for the seed bed. And usually they use something like a harrow or a disc. A harrow is a toothed or spiked implement that levels the field and breaks up soil particles. There's one on the top picture. And a disc has big concave plates or discs, round plates with sharp edges that kind of slice through and mix the soil. And if you have a disc with large enough plates, they have been used for primary tillage. And most discs will incorporate materials from 3 to 6 inches into the soil. And so conservation tillage is an approach that leaves just any tillage type that leaves 30% or more of the crop residue on the soil surface. And it's used about, give or take, 40% of the acres in the United States. And the purpose is for the reducing soil and water erosion. It's very important to have some sort of cover on rather than bare soil that can wash away or blow away. And it's made possible by types of equipment that can plant directly into residue and also herbicides for post-emergence control of weeds. With conservation tillage, you're a little bit more dependent on herbicides because you don't have the tillage activity that will kill the weeds. And there's different conservation tillage approaches: mulch tillage, ridge till, and no-till, and strip till are all conservation tillage approaches. We'll go over those. And mulch tillage is just, it includes 1 to 3 tillage operations. The primary tillage implement is a chisel plow. There's one showing on top there. And that's just kind of an enlarged field cultivator that has shanks that you can attach different tools or blades depending on what you want to do. And it doesn't totally turn the soil over. The picture on the bottom shows kind of the tillage pattern. Of the top is a moldboard plow, and the bottom of the little picture is kind of shows what a chisel plow does. And you can see the moldboard plow turns it totally over, and the chisel plow slices down into the ground, but it doesn't totally turn the soil over. And so it minimally incorporates the residue, so it leaves a lot more of the residue on top. And it does penetrate down to about 10 inches. And then after chisel plowing, a secondary tillage with a disc or a harrow of some type is done. And no-till is one that does not use primary tillage at all. It uses a specialized planter that has disc openers that slices through the crop residue and deposits seed at whatever depth you need. And in this case, there's minimal residue disturbance and soil erosion because you're actually planting into the residue of the last crop. And then also conserves soil organic matter and water. And it's somewhat problematic in northern areas, depending if it's a wet year, like winter, wet spring, because the surface residues will insulate the soil and it warms up too slow in the spring and can delay planting, in an area that has a short growing season anyway. So some people have resisted using it just for that reason. And there's some controversy among soil scientists and crop scientists over, whether, what the benefits and risks of using it. And then ridge tillage is used with row crops such as corn and soybean, kind of in areas like Iowa, Indiana, and southern Minnesota. Maybe it's used a little more than it would be used in North Dakota. And so what happens here is during the last cultivation of a row crop, ridges are created about 6 to 10 inches high. And the next year, the crop is planted directly into the top of the ridge. And the ridge is maintained through the years with cultivation. And the advantage to this is in the spring, the ridges warm up and dry faster than the surrounding soil. And there's also a version of this that's used in maybe drier areas where instead of planting on top of the ridge, they'll plant in the area between the ridges. And that way that will hold water and conserve water a little more. And then strip tillage is done with special equipment that creates basically just little 8 to 12 inch bands are tilled, and that's where the seed is planted. And so the residue in between the rows is similar to a no-till system. You just have this equipment with coulters and slicers, kind of that just tills these little narrow bands where you plant the seeds. And then the seed bed is also warmer, like compared to tillage with a chisel plow. And the yields are comparative to chisel plowing, but also there's less time and energy. But this also doesn't work well with corn in the north because the heavy residue can reduce temperatures and once again delay planting. And here's just a comparison of the different tillage types. You see conventional tillage has the 4 operations: plowing, disking, planting, cultivating. And something like reduced tillage is kind of in between no-till and conventional tillage, and it's got just basically no primary operation, just disking, planting, and cultivating. And then no-till is just planting and spraying only. There's no tillage operation at all. And so conservation tillage is, by definition, leaves 30% or more residue after planting. Reduced till leaves between 15 and 30%. And conventional tillage usually leaves 0 to 15% residue after planting. And timing of plowing is also important, and just spring or fall plowing has advantages just depending on the situation and also where you live. So fall plowing allows for breakdown of crop residue during the winter and also faster warm-up of soil in the spring, and allows earlier planting the following spring because you only have to do secondary tillage. The problem with if there's too much fall plowing, sometimes if there's a year when there's not a lot of snow cover, there can be a lot of blowing and erosion of if there's like bare soil left all winter. And then spring plowing, for that reason, leaves more crop stubble on the surface during the winter, and that'll reduce the erosion, but it also may delay planting on wetter soil. So you kind of have to use your judgment for what you want to use, depending on the weather at the time and also your type of soil. And then crop establishment, the important things for crop establishment. Most crops are established from seed, and early farmers, your grandparents, or maybe even your parents, would save the seed from the best plants to replant the next year. But today, most farmers purchase seed for crops grown in a large acreage from a commercial seed company. And seed companies and plant breeders, if they've developed varieties that, themselves, they will legally protect the genetic traits of their developed varieties. And so if you're using one of these varieties, it's illegal to save and plant or sell the seed if the variety has a patent or is owned by a company, you can get in trouble for doing that. And there's federal seed laws, are laws that exist to give farmers and consumers information about the seed that they purchase. And also provide for seed that's sold must be labeled and contain certain information that's required by law. And then seed certification, the seed certification process just ensures that the genetic uniqueness and quality of the seed, and also regulates seed production for consumers. It's regulated by state crop improvement associations. So basically growers who buy certified seed are assured of buying quality seed. So you know what you're getting, and you know that it's good seed, basically. And this graph just basically shows all the information that's required on a seed tag, and it's also this is right in your book, so I won't go into it in a lot of detail, but basically things like the crop type, variety, the lot, which is the specific quantity of seed that's produced at a certain time in a certain place, and then the percentage of pure seed, like how much of it is actually crop seed, because there's other stuff that might be in there. And if there's any other crop seed that's contaminating it, any percentage of weed seed or other inert stuff, and then also the date that it was tested. The origin is the site where it was produced, and then the name of the seed company. And this slide just gives information about how you calculate pure live seed and seeding rates from the information on a seed tag. And basically, the pure live seed is a product of the percentage of germination, which is just if they do a germination test, what percentage of the seed is going to germinate, and then that's times the percentage of purity, and that's so basically the amount of the percentage of germination is given on the seed tag, and then also how much inert matter and other crop seed and weed seed is contained in there. So you just would subtract that stuff, all the inert matter and other stuff that isn't crop seed from 100%, and you would get the amount that is actually pure live seed. And then, so in this case it's about 97%. And then you would take that percentage times, the germination, and that would give you the amount of pure live seed. So it's basically how much of it is actual crop seed and how much of that is going to germinate. So in this case, it would be 90%. And the reason this is important, because you can use that to determine the amount of seed that you need to seed a crop at a recommended rate. Like example, if you're told to seed 55 pounds per acre for soybeans or whatever, in this case, the 90% would be the pure live seed, and you would basically take 55 pounds divided by 0.9, which is 90%, and that would give you 61% approximately. And what that means is that you would have, in order to get 55 pounds per acre, you would have to seed 61.1 pounds per acre to make up for the inert matter and basically the amount of seed that won't germinate. And successful seeding also depends on planting depth. So if the seed is planted too deep, it will use up all its energy before it gets to the soil surface, where it can start doing photosynthesis and making its own energy. But a seed that's planted too shallow might dry out and die before it can produce roots that can get water. And so the general rule of thumb is that seed should be planted no deeper than 10 times the diameter of the seed. And seeds with epigeal emergence, that's when the growing point emerges between the cotyledons, like soybeans, they'll be more hindered by soil crusting, than those that have hypogeal emergence, like grasses, because in those cases the growing point is still below the ground. But it's like that soybeans have a really hard time coming through crusted ground. It really stresses the plant. And so seeds should in general be planted as deep as possible within the recommended planting range. That's just to maximize the chance of contacting moisture. If they don't contact moisture in the soil, they won't. They may dry out and die before they even have a chance to grow. And in general, crops are planted deeper in sandy soils than clay soils because clay soil has more pore space and also lower water holding capacity than clay, so you would maybe want it a little deeper, and it's also less subject to crusting if it does rain. And there's several environmental factors that affect seed germination. Moisture, before planting, seeds contain less than 15% moisture, and most seeds won't germinate until they reach a critical level of moisture. They have to start absorbing moisture, like usually it absorbs 100% of its dry weight if it's a sugar beet seed. Soybeans need to absorb 75, corn 40%. So unless they've absorbed that much moisture, they won't start growing. And so actually drilling seed into the soil will increase the chance that the root will grow down into a moist area of the soil. And because moderate pressure by the press wheels and the drill will increase moisture availability by increasing soil to seed contact. You don't want it too compact because then there's no airspace, but the soil has to come in contact with the seed so it can imbibe moisture. And then temperatures affects all the metabolic reactions in plants. They tend to slow down at lower temperatures, speed up to a certain point at higher temperatures. So warm season plants like corn and soybean have a higher minimum and maximum temperature for germination than cool season plants like wheat or alfalfa. And so the minimal temperature for germination for cool season plants is about 40 to 50 degrees Fahrenheit. That means that's the lowest temperature at which they'll start growing. And minimum temperature for warm season plants is 50 to 60. They need it a little warmer to start growing. And then oxygen is necessarily for processes like respiration. But usually oxygen isn't a limiting factor unless the soil is really compacted or it's flooded, when those are situations where there's no air. And rice is an exception because you may know rice, like the rice fields are flooded and the seeds actually germinate in anaerobic conditions underwater. So in that case, it needs water, to be soaking in water to germinate. And as far as light, most species can germinate in light or darkness, but there's some small seeds that germinate near the surface that actually need light to germinate. And then dormancy is a condition that means it's just a failure to germinate when all required environmental conditions are met. And actually, this is an important evolutionary characteristic that's developed to prevent seed from germinating when it's still on the plant too early. But it's not desirable. It also protects seeds in cases of like environmental, bad environmental conditions. But it's not desirable in seed intended for planting. You want it all to germinate at the same time. And there's some legumes, some like beans, peas, in that family. They have specialized layer that keeps out water and air, and in those cases, they won't germinate unless they're scarified, and that's like something has to scratch the seed code. And there's others that have chemical compounds that have to be leached out from the seed before germination. And this is just, once again, it's from your book, so I won't go into it in too much detail. It's just relationship between plant population and yield. This is just for Minnesota. I think it's relationship between corn plant population and grain yield for corn planted prior to May 1st. And so basically, like the plant population per acre was 30,000 per acre. The grain yield was 100%, and the yield went down as the plant population declined. So that's kind of important. That's why one reason it's important to get the correct plant population per acre to get the yield that's required. And it'll drop off quite significantly if something happens like hail or drought or something, that if all your seeds don't germinate or something like that. And then seed treatments. There's many crop seeds are treated before purchase for things like soil fungi, insects that can attack the seed before and during germination. And for some of those situations, treated seed is the only option to prevent certain diseases and insects. And there's like legumes like soybeans and alfalfa can also be treated with a specific rhizobium. That's a nitrogen fixing bacteria. And those are species specific. You have to have the one for, if you're planting soybeans, the one for alfalfa or whatever won't be effective on it. And then the next few slides just deal with different types of seeding and planting material, planting equipment. And as far as like there's broadcast seeding consists of just spreading seed on top of the seed bed across the entire field. Basically, that just means not in rows. And that would be used for really small seeded forage plants like alfalfa. It's like this is like a broadcast seeder for alfalfa. It's got rollers that basically, it's like basically that smooths out the field, and then there's it plants the seed, and then there's another roller that comes after it. And some farmers practice what's called frost seeding, and that's just broadcast seeding forage grasses and legumes while the ground is still frozen, and then the seed is covered as the soil freezes and thaws. And then drilling consists of basically depositing seed in a row at a uniform depth in a seed bed. And most drills have like a hopper that has where you have seed and fertilizer, and then there's a metering device for a specific seed size, and openers, which are called drills. That's why it's called drills, for just placing the seed in the soil. And there's different types. Grain drills plant grain like wheat or whatever in narrow rows about 6 inches apart, and those are the traditional approach for planting wheat and barley, basically small grain plants. And there's some no-till grassland drills that are used to interseed vegetation into existing grasslands, areas maybe that they're, trying to preserve the grassland or, for pasture seeding or whatever. And they're heavy, and they've got specialized disc openers that have to slice through and throw existing vegetation. And we just kind of basically planting grass and other vegetation in without totally tearing up the existing grassland. And then row crop planters are used for crops like corn and soybean, and deposits the seeds in rows 15 to 30 inches apart, depending on the crop. And there are no-till variations that are equipped with coulters and discs that remove the residue of previous crops, kind of throw it out of the way, and plant around the residue. And then air seeders are fairly new in relation to some of the others. They basically use a stream of air to inject the seed into the soil. And they're mainly used for smaller seeds like grains, but they can be used for soybeans. And one advantage is they can plant a large amount of seed in a short time, but they're heavy, expensive, and the lines can clog. And some of those things are being improved as newer models come out. And then the importance of row spacing. So over time, row spacing for corn and soybean has decreased. We plant those crops much closer together than our grandparents did and people for longer ago. And crops like corn used to be planted in rows about like 48 inches, which is like 4 feet apart. And the purpose of that was to make room for cultivation equipment for weed control, because they didn't have the herbicide advantages that we do. So they had to be able to cultivate between the rows. And today, corn's usually planted in rows 30 inches apart. There's some research and questions about whether closer spacing or like twin rows and things like that can be used. There's controversy over some of that. And soybean yield can also be significantly enhanced by planting in 15-inch rows and then using herbicides for weed control. And like closer rows can intercept more light and use moisture better because the plants are equally spaced in the field. And also the plants will tend to, especially like corn, they'll close the canopy sooner. And that's really important for weed control, in certain crops where, have a closed canopy as soon as possible. And then as far as the importance of planting dates, it's going to depend on the crop, but generally cool season annuals like small grains, wheat, or things like that are usually planted as early as possible to take advantage of the favorable environmental conditions. And then they mature during the warm summer months. And then like warm season plants like corn and soybean and cotton are planted later because they're they need higher temperatures for germination because of frost sensitivity. I mean, they're not going to grow if the soil, like it said before, they're not going to grow anyway if the soil is below 50 degrees. And they're really, especially like soybean, some of the others are, the dicot plants are really, broadleaf plants are really susceptible to frost if there's a frost after the seedling comes up. And then there's winter annual crops like winter wheat are planted in later summer to early fall, and then they overwinter and then, start growing in the spring again. And most of those, naturally do better in areas of milder winter conditions, just, because if it's a really severe winter, it could kill the plant. Okay, that's all we have for that. Once again, go over your notes and everything else and let me know if you have any questions.